Hello students, welcome back to the second video of this playlist. In this video, we will be solving question number 2 from the one of the most recent past paper of further pure mathematics, which is the May 2024 F1 paper. So let's get started with the second question of this paper. So here, a function f of z, it is given as f of z equals to z cubed negative 13z squared plus 59z plus p, where p is element integers. Okay, so given that z equals to 3 is a root of the equation f of z equals to 0. Okay, so part A here is asking to show that p equals to negative of 87. Okay, so z equals to 3, it's basically a root, right? So using the concept of factor theorem, we can say that f of 3 would be equal to 0, right? So let's substitute 3 into the equation of f of z. So that would give you 3 cubed negative 13 times z squared, which is 3 squared, and then plus 59z, so 59 times 3 plus p equals to 0. Okay, so 3 cube is 27 minus 3 squared is 9. 9 times 13, it is basically 117 plus 59 times 3, it is basically 177 plus p equals to 0. Now just make p the subject to get the value for p. So 27 minus 117 plus 177, this is basically 87. So if you take it to the right side, it will become negative of 87. And that's what part A of question number 2 has asked to show. Fine. Okay, next is part B. In part B, the question is asking to use algebra to determine the other roots of f of z equals to 0, giving your answers in simplest form. Okay, so we need to figure out the other roots of f of z. Okay, so we already know that z equals to 3 is one of the root, right? So we can z equals to 3, we can consider this root to approach the answer for part B. So z equals to 3, it's a root, so we can consider z minus 3 equals to 0. So z minus 3, since z minus 3 equals to 0, therefore we can say that z minus 3 is a factor of f of z. Okay, so now we will use algebraic long division. Using algebraic long division, we will factorize the given function. So z minus 3, let's factorize it. The equation is basically z cubed negative 13z squared, z cubed negative 13z squared plus 59z, if I'm not wrong, yeah, plus 59z negative 87. So plus 59z negative 87. Okay, so what we need to do at first, we need to multiply by z squared with z minus 3 to get z cubed negative 3z squared. Why we have multiplied by z squared? So that z cube gets eliminated. Okay, as you subtract the second expression from the first expression. Okay, so z cube cancels out, so negative 13z squared minus 3z squared. So minus 3, it will become plus 3z squared. So that would give you negative 10z squared. Now we need two terms there. So take 59z there. So 59z, if this is 59z, so we have to multiply by negative 10 to eliminate negative 10z squared. So negative 10z, not only negative 10, negative 10z. So negative 10z times z, that would give you negative 10z squared and plus 30z. Okay, same way, negative 10z squared and negative 10z squared cancels out. So 59z minus 30z, that would give you 29z. Okay, 29z. So we need two terms. So take negative 87 down. So 29z. To eliminate 29z, we have to multiply by 29 with z minus 3. So you will get 29z minus 29 times 3, it is basically 87. So the remainder is 0. Okay, so that means we got the equation f of z divided by z minus 3, that would give you z squared negative 10z plus 29, z squared negative 10z plus 29. Okay, so that means f of z can be written as z minus 3 times z squared negative 10z plus 29. Okay, so we have to consider f of z equals to 0, right? So since f of z is equals to 0, so either z equals to 3 or z equals to, use the quadratic formula, minus b plus minus square root of b squared minus 4ac. So b squared is 10 squared, that is 100, minus 4 times 29, that would give you negative 16 over twice of a, which is just 2. Okay, so z is either 5, 10 over 2 is 5 plus square root of 16, that is square root of 16, we can write it as square root of negative 1 times square root of 16. Okay, we have just taken negative 1 outside over 2 plus minus, right? There is a plus minus. Okay, so either z equals to 5 plus 4 over 2, it is 2i. Square root of negative 1 is basically I, so 2i or 5 minus 2i. Okay, so the other two roots of f of z equals to 0 are basically z equals to 5 plus minus twice of I. That's it. These are basically complex roots, and that's what part B of question number 2 has asked to find out. Fine. Okay, next is part C. Okay, the question says here, on an Argand diagram, the root z equals to 3 is represented by the point P. Okay, the other roots of f of z equals to 0 are represented by the points Q and R. The number z equals to negative 9 is represented by the point S. So part C is asking to show on a single Argand diagram the positions of point P, Q, R, and S. Okay, so we have to show the roots and also an extra point on an Argand diagram. Okay, so this is for part C. Let's draw the axis of the Argand diagram first. So this is the y-axis. On the Cartesian axis, for Cartesian axis, this is the x-axis, but for Argand diagram, we consider the vertical axis, it's for the real and imaginary, it's for the imaginary part. Okay, and the horizontal axis, it's for the real axis, it's for the real part of the root of the complex number. Okay, so the first one, it is z equals to 3. So let's say z equals to 3. Let's say, let me change the color as we consider the straight line. Take red color. Okay, so let's consider this is z equals to 3. Okay, this point is z equals to 3. So z equals to 3, it is represented by the point P. Okay, this is point P basically. This is point P. Okay, next is 5 plus minus 2i, right? So 5 plus minus twice of I, let's say 5 plus twice of I. So this is 3, right? So let's go a bit to the right. So this is 5 and plus 2i, let's say it is there. Okay, so this is 5 plus 2i, and this is basically 5 minus twice of I. It should be equidistant. Okay, 5 minus twice of I. Okay, so these points are P, Q, R, S. So let's say this point is Q. It can be anything, no problem. This can be Q, this can be R. Fine. And at last, S. Point S is basically -9. So -9 would be there. Okay, this is basically -9. Okay, so this point is basically -9i. Just -9. Sorry, it's just -9. So P, Q, R, and this point is basically S. Done. These are the 4 points on the Argand diagram, and that's what part C has asked to show. Fine. Okay, next is part D. In part D, the question is asking to determine the perimeter of the quadrilateral PQSR, giving your answer as a simplified SAD. Okay, so we need to find out the perimeter of the quadrilateral that has been formed in the Argand diagram. We can figure it out. Let's have a look. PQRS. So basically, if I use some dotted lines, so the shape would be like this. P, okay, this is SQ, then PQ, and then PR, and then RS. So the length of SR and SQ are equal. Again, the length of PQ, PR, it is also equal. So we will just need to find out the length of PQ and SR. Okay, so let's figure out the length of PQ and SR. Okay, let me erase them. Okay, we need black ink. Okay, for part D, we need the length of PQ and SR. So length of PQ equals to P to Q. Okay, so the position of P, it is basically 3, 0, and the position of Q, it is basically 5, -2. Okay, so square root of y2 minus y1 whole squared. So 5 minus 3 whole squared plus x2 minus x1 whole squared. So -2, -0 whole squared. So that much units. So 5 minus 3 is 2, 2 squared is 4. So 4 plus 4, it is 8. Square root of 8, it is 2. Square root of 2 units. That's the length of PQ. Okay, we got the length of PQ. Next is the length of SR. Okay, the length of SR or SQ. Okay, let's consider the length of SQ. Same thing, no problem. So SQ, point S has coordinates. This is point P, this is Q, and this is point S. Point S is -9, 0. Okay, so SQ. So 5 plus 9 whole squared, square root of 5 plus 9 whole squared, 5 plus 9 whole squared plus this is x2 minus x1 whole squared plus y2 minus y1 whole squared. So -2, -0 whole squared. So that would give you that much units. So 5 plus 9 is 14. 14 squared, it is basically 196 plus 4, which is square root of 200. So square root of 200, it is 10 square root of 2 units. Okay, so now the perimeter. So what I showed earlier, perimeter of PQRS, it is twice of the length of PQ and SQ, right? Twice of the length of PQ and SQ, because the sides are equal, that's why. So PQ, it is 2 square root of 2, and SQ, it is basically 10 square root of 2. So 10 square root of 2 plus 2 square root of 2, it is 12. So 12 times 2, it is 24 square root of 2 units. That's the perimeter of the quadrilateral PQRS. And that's the end of question number 2. Fine.